Hello, and in this video we will be going over A-level physics, specifically for EDEXCEL. We'll take a look at measuring refractive index of a solid material, and we'll also take a look at understanding the terms focal length of diverging and converging lenses. So specification point 74 states that we need to understand how to measure the refractive index of a solid material, and specification point 75 states that we need to understand the terms focal length of converging and diverging lenses. So, to measure the refractive index of a given solid, we can use a ray box to find the refractive index of a glass block, as an example. So we place the glass block on paper, we draw around the glass block, then we're going to use a ray box to shine the light beam into the glass block, turn off other background lights so you can see the light path through the block, trace the path of the incoming and outgoing beams of light, remove the glass block and join up the incoming and outgoing paths with a straight line. Measure the angle of incidence and the angle of refraction from the normal line. Since glass is more optically dense than air, as light enters the glass block, it would move towards the normal line, so light is slowing down. Now once the beam of light leaves the glass block, it would move away from the normal line and therefore speed up. Now we can use Snell's law, which is given as n1 multiplied by sine theta 1, which is equal to n2 multiplied by sine theta 2, and rearrange it to make the refractive index the subject of the formula. So we end up with n1 multiplied by sine theta 1 divided by sine theta 2 is equal to n. We substitute in n equals 1 for air, and the values for theta 1, which is the angle of incidence, and theta 2, which is the angle of refraction. And based upon that, we would then be able to find the refractive index of the given material. Now moving on to lenses, we need to understand what lenses are. So lenses are optical devices which work by changing the direction of light, and this process is known as refraction. Now for converging lenses, the focal length is basically defined as the distance between the lens axis and the focal plane. And some key facts for converging lenses are that they cave outwards, and light rays parallel to the principal axis converge onto a point called the principal focus, which is also referred to as the focal point. Now the focal length is positive for a converging lens as it is in front of the lens. For diverging lenses, the focal length is basically defined as the distance between the lens axis and the principal focus. Some key facts about diverging lenses are that they cave inwards, and the principal focus, which is also known as the focal point of a diverging lens, is behind the lens. Incident rays which are parallel to the lens axis are assumed to have come from an infinite distance away. Therefore, the light rays diverge once they reach the lens due to refraction. Now, if the rays of light are joined up by dotted lines as shown in the diagram, then we can see where the focal point is located. So to kind of clarify one more time, if we have a look at the top image, that shows the image of a converging lens. As we can see, we have incident parallel rays of light going towards the lens, and there is a dotted line going down the middle of the lens, which is basically defined as the lens axis. Once it hits the lens axis, it then refracts and begins moving until it converges at a certain point with other rays of light, and that given point is referred to as the focal point, and the distance between the lens axis and the focal point is referred to as the focal length. Now, for the next image, which is the image below the converging lens, which shows a picture of the diverging lens, we have parallel incident rays of light going towards the lens axis, and once they hit the lens axis, they then diverge and go onto different paths. Now, using dotted lines, if we kind of go back and trace dotted lines, we can see that they actually converge at a given point, which is referred to as the focal point. And the distance between the focal plane and the lens axis for the diverging lens is referred to as the focal length. Thank you all for watching. I hope this video has made sense and cleared any questions anyone's had about measuring refractive index of a solid material and understanding the focal length of diverging and converging lenses. Thank you all for watching, and goodbye.